the fuck will यत्रो दिन के लागि गरेर चाहिँ गर्न नि छोडेको होइन जब नि गर्न पाएन घरमा नि बसिरहेको छु यत्तिकै कलेज पढिरहेको केही प्रोडक्टिभिटी छैन कलेजमा नि त्यो के हुँदैन त्यो जस्ट अ सिट अफ पेपर देयर इज नथिङ एल्स त्यो कलेजबाट and still struggling dude time is fucking like college go what the fuck am I doing then dude yeah जोसै गयो मेरो पढ्ने जोस yes. I'm just giving up everything shortcuts खोजिरहेको छु shortcut try fucking kill it अब यो छोडेर गइहालेँ उसैको लागि गर्छु भनेर पढेको थिएँ I'm fucking lonely depressed right now Mm, एक सेकेन्डमा मर्न सक्ने भयो भने मर्थेँ म गयो नि त without any pain yeah but आखिर केको लागि आफ्नै लागि गरेर गर्ने so you have to fucking read mm, I have to fucking read get a decent job त्यसपछि एक्सर्नल कुराबाट like why did you leave me on I'm not going with her फेरि अब never धेरै टर्चर खाइसक्यो that's awesome. I can't erase her from my memory, dude. What the fuck? Too much shit left. त्यही बेला छोड्नुपर्ने मैले म्युजिक यो चाहिँ एक्लै भने डरले गरेन मात्छु नि त्यही त बुद्धि भएन नि मेरो आजसँग कसरी डिल गर्ने नि थाहा छैन मलाई यो फ्यामिली नि खतम भएर त्यही त घरबाट आमाले नै खाना छ काज गरेर ठिक छ अहिले भन्दा मिल्दै अब झगडा सोच पैसा कमायो भने माथि नि कसम जति पैसा खर्च गरे त्यो दिएर कनेक्सन कट गरेर एक्लै बस्नु यिनीहरूबाट fucking tired of this family. Yeah, life is suppressed basically यिनीहरूले गर्दा केही गर्न दिँदैन मेरो पढ मात्र लाग्यो पढाउने नि होइन फेरि कसरी भन्ने के आइडिया दिने पढ यत्तिकै छोडेर They don't know anything. These motherfuckers. अनि काम छैन। इम्प्लोइ बुद्धिहरू सबको। यस्तो बुद्धि हुनु पर्यो आर्मी पढ्नु भनेको सिधै राम्रै। त्यही त पैसा त चाहियो रहेछ मुली पढ्किन भनेर चिनी यिनीहरूले त्यही त जिन्दगीभर पढ भने लाख पैसा हाइड्रोलोजिकल हाइड्रोलिक्सन रेनफल रन अफ ग्राउन्ड वाटर स्टोरेज फ्लोर and मामा चाहिँ पढेमा त एकदम money. So yeah, there is that no plot lines for that will matter also. तिनीहरू चाहिँ पैसा कमाउनु पढेर काम yeah, should start socializing. पैसा कमाउने भयो पब्लो सुन्ने पैसा कमाउँछ fuck you are. But if you want to evolution सिस्टम चेन्ज गर्नु चाहिँ पढ्नुपर्छ yeah, पढ्नु मात्र होइन इम्प्लिमेन्ट गर्नुपर्छ त्यो मैले नेपाली सिकाउँदैन त्यहाँ hydrologic are the hydraulics and rainfall runoff, groundwater, stream flow, and irrigation, SMDN. Soil or land is surface of gully erosion, mass failure, landslide and Davis flood. भोलि बर्थडे मेरो कति छ 2 घन्टा छ अब आउनलाई This could be my worst year. Yep. योभन्दा अगाडि पनि थियो वर्स्ट अहिले पनि वर्स्ट नै हुनसक्छ वर्स्ट बर्थडे छ इयर त भएन वर्स्ट बर्थडे कहिले बर्थडे मनाएको नमनाउँदा पनि yes it's a worst because I have no one I feel empty inside yeah, yeah I feel empty पहिलो ल्यान्ड जाने सरकार गलिएर जाने मास फेलियर यत्रो 24 वर्ष सरी 24 रे 26 वर्ष म चाहिँ 27 लाख अरे के करे जिन्दगीमा मुझे त्यो मुझे 50% जिन्दगी जान लाग्यो त्यही त या तँ 70 मा बाँच्ने हो 60 बाँच्ला ल 70-60 You have done nothing यार कि लाइफमा के गरेँ होइन मैले कस्तो जिन्दगीमा मैले छ्या अरे यिनीहरूसँग खै पठाउनु हुने Early can give water level velocity and discharge of inflow, discharge of outflow, sediment morphology, sediment concentration, sediment transport, grain size, distribution, bathymetry, sediment quality, soil land use and surface gully erosions, mass failure, landslides and debris flood and deformations and the land use change and upstream river reservoir dam hydraulic and sediment are the morphology, soil or land use and sediments are morphology. Hydraulics and hydrologic water level velocity upstream reservoir river or dams and water level velocity discharge inflow discharge of outflow sediment morphology suspended concentration sediment transport grain size distribution sediment concentration sediment transport sediment morphology and sediment concentration sediment distribute transports grain size distributions bathymetry sediment quality sediment concentration sediment and transport sediment morphology sediment concentration sediment transports grain size distributions and sediment concentration, sediment transport. sediment concentration, sediment transport, grain size distributions, bathymetry, sediment quality, and sediment concentration, sediment transfer, sediment concentration, sediment transfer, grain size distributions, bathymetry, reservoirs, sediment quality. Sediment morphology, sediment concentration, sediment quality, and sediment transfer, sediment grain size distributions, and sediment concentration, sediment transfers, and grain size distributions, bathymetry, sediment quality. Hydraulic water level, velocity, discharge, and flow, discharge, flow, sediment quality, sediment concentration, sediment transfer, sediment grain size distribution, sediment transfer, sediment concentration, sediment quality and bathymetric tensile distributions. The surface or gully erosion, soil or land use, and surface or gully erosion, mass failure or landslides, and debris flow, mass failure, landslide, debris flow, sediment. Surface or the gullies, surface of gullies, surface of gullies, surface of gullies, and mass wasting, landslide, debris flow, and deformation, land use change. Runoff, rainfall, and groundwater streams flow. Okay, water level, velocity, discharge, inflow, discharge, outflows, and sediment concentration, sediment transportation, sediment quality, grain size distribution, bathymetry, upstreams, reservoir and dams, river reservoir and dam, and hydraulics, and the sediment morphology, catchments, hydrologic, hydraulics, and soil or land use, downstream reaches, hydraulics, sediments, and hydraulics, water level, discharge, and sediment concentration, grain size, and downstream reach, and hydraulics, sediments, and hydraulic water level, discharge, and sediment concentration, grain size. Hydraulic water level discharge and sediment concentration of green size and hydraulic and water level discharge and sediment concentration of green size downstream reaches and hydraulic water level discharge sediment and water level discharge sediment concentration of green size sediment concentration of green size hydraulic water level discharge and sediment concentration of green size and hydraulic water level discharge and sediment concentration of green size. Water level discharge, sediment concentration, grain size, water level discharge, and parameters to be analyzed and rainfall runoff again, you monitor the rainfall pattern and runoff responses. Rainfall pattern, rainfall runoff is not only rainfall pattern and runoff responses. Determine and get monitoring and the monitoring on the rain gauge and stream flow are used to record for the purpose rainfall, rain gauge, stream flow gauge, and groundwater recharge storage and the interactions with the surface water bodies and groundwater monitoring, groundwater level and the water quality and again the quality provide insight into the groundwater recharge and storage and the interactions with the water surface body stream flow water level and groundwater resource storage and the interactions and groundwater resource storage and groundwater resource storage and thus interactions with the water surface body. Ito so एकचोटि के साथ है कस्तो छ तँलाई? What do you need? Are you happy? Yeah, are you happy? Mhm. I need that. मुझी गर्लफ्रेन्ड सोधेन ल्यान्ड फ्यामिली सोधेन गर्लफ्रेन्ड के गर्ने एक्सले सोधेन क्लोज त्यही थियो यार मुझी त्यही भएर नि म बोला क्लोज भयो जस्तो लाग्दैन कस्तो माफिया मेरो चाहिँ Synchronic water level, velocity, and discharge helps understanding the dynamics of the river flow and its response to the event, precipitation events. And water level velocity and the discharge helps in understanding the dynamic of the river flow and water level velocity and the discharge helps in understanding the dynamics of the river flow and its response to the precipitation events. And water level and velocity and the discharge, water level velocity and the discharge helps to understand the dynamics of the river flow. Water level velocity and the discharge helps to understand the dynamics of the river flow and its response to the precipitation events. And water level velocity and the discharge. Water level velocity and the researchers to understand the dynamics of the river flow and its response to the precipitation events and groundwater research stores and interactions with the surface water bodies and monitoring of the groundwater level and the quality and monitoring of the groundwater level and the quality provide insight into the groundwater reserves, storage and interactions with the surface water body. Water level velocity and the discharge helps to understanding the dynamics of the river flow and its response to the precipitation events, soil or land use and monitoring. Soil or land use monitoring and surface or the gully erosions and mass failure or the landslides and debris flow and deforestation and the land use change and म बाहिर दिनुपर्ला जस्तो लाग्यो मसँग बस्नु मात्रै मलाई बाहिर बस्ने काम गर्ने बाहिर भए पनि This is so wrong तर त्यही त 50,00,000सँग राख्ने just because you are insecure of your future हेर्दैन भन्ने डरले life isn't about competition it's about survival being happy people धेरै evil छ people I am not aware of how much evil people are आफू खुसी खै तलको त बिगार्छ भन्ने बस Soil erosion measurement of the soil erosion rates and sediment transport helps in assessing the impact of the land use practices such as agriculture, deforestation, soil erosion and the sediment yield and measurement on the soil erosion rates and the sediment transfers and soil erosion rates and the sediment transfer measurement of the soil erosion rate and sediment transfer helps to access the any measurement soil erosion rates and surface transfers helps to access the impact on land use practices such as agriculture, deforestation, on soil erosion and the sediment yield and mass failures on your landslide debris flow and monitoring of the slope stability inside an occurrence. Monitoring of monitoring of the slope stability, landslide occurrence and debris flow and provide early warning and helps mitigating the risks and monitoring of the slope stability and landslides occurrence and slope stability, landslide occurrence and the debris flow helps to provide early warning and mitigating the helps in mitigating the risks associated with the mass wasting phenomenon. Deforestations and the land use change and the remote sensing techniques and land use maps and the field survey used to monitor the change in the land order and land cover and the land use which influence the hydrological process and the sediment transport dynamics. Remote sensing techniques, land use maps and remote sensing techniques, land use maps and the field survey used to monitor the change in the land cover and the land use and which influence the hydrological process and the sediment transport dynamics and still change in the land change in the land is field surveys to monitor the change in the land cover and the land use which influence the hydrological process and transfer dynamic. Hydraulic monitoring water level velocity and water level velocity discharge inflow outflow and water level sensor gauge are used to and inform on the upstreams अनि catchments को कुरो गरेको थिएँ होइन रिमोट सेन्सिङ एप्स अनि यता अपस्ट्रिम्स वाटर रिजर्भर त अनि रिभर रिजर्भर ड्याम वाटर लेभल अनि वाटर लेभलले चाहिँ अनि कति भोल्युम स्टोर गरेको छ रिजर्भर स्टोरेज एन्ड रिभर स्टेज भेरिएसन्स थियो भेलोसिटी भनेको चाहिँ अनि एकोस्टिक डपलर प्रोफाइल त्यसबाट थियो अनि युज टु मेजर द भेलोसिटी इन द रिभर एन्ड रिजर्भर त्यति मात्रै छ टेक्निक चाहिँ अनि एकोस्टिक डोप्लर्स अनि करेन्ट प्रोफाइलर्स अनि एकोस्टिक्स डोप्लर करेन्ट प्रोफाइलर्स water level sensors are the gauge sensors provide information on the reservoir stress and the river stage variations and influence the outflow discharge monitoring influence the outflow discharge rates helps in managing the water resources flood control and hydropower generations and monitoring of the inflow and the outflow discharge rates and monitoring of the inflow and outflow discharge rates helps in managing the water resources, flood control, and the hydropower generations. And the sediment morphology monitoring sediment concentrations and sampling and the laboratory analysis are used to measure the suspended sediment concentration and the bed sediment load. And suspended sampling and the laboratory analysis are suspended sediment concentration and bed sediment load. Sediment transport techniques such as sediment trap, sediment sampler, and the acoustic instruments used to monitor the sediment transfer rates and the pattern grains as distribution sediment samples are analyzed to determine the distributions of the particle size which influence the sediment transport behavior and the channel morphology. Yeah, त्यो राम्रो कुरो हो मनको कुरा लेख्नु के फिल गरेर अहिले त्यो भनेर इट्स भेरी नाइस त्यो कुरा यो पछि कम्पाइल गरेर झन् राम्रो बनाउनु पछि सोचेर पछि लेख्छु भने नि या द्याट charisma will disappear. You know it right. बनावटी बनाउनु खोज्छ so बिग्रिँदैन cannot be a Sediment and morphology monitoring, sediment concentration sampling, and the laboratory analysis are used to measure the suspended sediment concentration and the bed sediment load. Sediment transfer techniques such as sediment trap, sediment sampler, and acoustics instrument used to monitor the sediment transfer rates and the pattern. कहाँ चाहिँ हो यो फेरि sediment morphology, sediment concentrations and laboratory analysis, suspended sediment analysis and used to measure the suspended sediment concentrations and sampling and the laboratory analysis used to measure the suspended sediment concentration bed load upstream reservoir downstream reservoir. Sediment transports and taking sediment traps and transports and traps, samplers and the acoustics instruments used to monitor the sediment transport rate and pattern. Okay, kun instruments on the sediment traps and sediment samplers and acoustic instruments, grain size distributions and sediment samples are analyzed to determine the distribution of the particle size which influence the sediment transport behavior and channel morphology. Bathymetry, hydrographic survey and the sonar techniques used to measure the map survey sediment depositions and the erosion pattern over time and sediment quality, accessing the sediment contamination potential impact ecosystems and the water quality. Downstream is hydraulics, water level discharge and your sediment concentration, grain size, water level and flood forecastings, navigations, water resources management, discharge, water availability, flood risks and the environmental flow requirement and water availability, flood risks and measurement of the river discharge provide information on the water availability, flood risks, environmental flow requirement, water availability, flood risks, environmental flow requirement. Sediment monitoring, sediment concentration monitoring of the suspended sediment concentration and the bed sediment load helps in accessing the sediment transfer dynamics and sedimentation rate and monitoring of the suspended sediment concentration and the bed sediment load monitoring of the suspended sediment concentration and sediment bed load helps in accessing the sediment transfer dynamics helps in sediment transfer dynamics and the sediment rates and water level and helps in the continuous monitoring of the water level helps in flood forecasting, navigations and water resources management. Flood forecasting, navigations and water resources management, discharge and measurement of the river discharge and provide information on the water availability, flood risks and the environmental flow requirement. Provide and information on the water availability, flood risks and the environmental flow requirement and discharge measurement of the river. Provide and discharge measurement of the river discharge and provide information on the water availability, flood risks and the environmental flow requirement. Sediment monitoring, sediment concentrations and helps in accessing the sediment transport dynamics and the sedimentation rate and green size helps to sediment transport process, channel morphology and sediment depositions pattern at downstreams. Unless sediment samples provide insights into the sediment transfer process and channel morphology and the sediment depositions pattern downstreams. Sediment transport process and channel morphology and sediment depositions pattern downstreams. Grain size and sediment concentrations and accessing the sediment transport dynamics and the sedimentation rate and sediment monitoring is important and as it sediment carry the pollutant, nutrient, and the contaminant affecting the water quality. Monitoring sediment concentration helps and access the level of the contamination potentials, impact level of the contaminations of the sediments in the water, and determine the level of contamination sediment in the water and potential impact on the water resources and ecosystems impact and alter the habitat and water quality may impact on the habitat, may impact ecosystems, may impact on the habitat structure, reducing the light penetration and smoother benthical organisms, affecting the aquatic biodiversity, ecosystem health, monitoring sediment dynamics helps in accessing and mitigating this impact on the aquatic ecosystems. Impact on infrastructure leads to the challenge and leads to the impact on the impact on the ecosystems, affecting biodiversity, ecosystem health, and impact on the infrastructures leads to the channel erosions and sedimentation, the reservoir dam to damage to the infrastructure such as dam, debris and water intakes and understanding erosion and the sediment transports and sediment monitoring provide the valuable data for the studying of the erosion process, sediment transport mechanisms, and sedimentation pattern. Provide valuable data for understanding the erosion process and impact on the infrastructures, impact on ecosystems, impact on the water quality. Understanding erosion and sediment transport provide data on the studying of the erosion process, sediment transport mechanisms provide data on the erosion process, sediment transport process mechanism and sedimentation pattern, erosion process, sediment transport mechanisms and sedimentation pattern, which is essential for predicting the erosion risks and erosion process sediment transport mechanisms erosion process sediment transport mechanisms sedimentation pattern erosion process sediment transport process sedimentation pattern and erosion process sediment and transport mechanisms erosion process sediment transport mechanisms and sedimentation pattern and pattern कसरी erosion process कसरी sediment transport कसरी हुन्छ अनि pattern कसरी बनाउँछ which helps to अनि के अरे essentials for predicting the erosion risks and manage the sediment and transport in the river and design control erosion control measures predict the erosion risks and results in provide the information essentials for predict the erosion risks, manage the sedimentary transport in the river, predict the erosion risks, manage the sediment transport in river, and design the erosion control measures and monitor as the part of the डिजाइन इरोजन कन्ट्रोल मेजर्स अनि डिजाइन कन्ट्रोल मेजर्स प्रोभाइड गर्छ अनि प्याटर्न त्यो सेडिमेन्ट ट्रान्सपोर्ट प्याटर्न इन द रिभर अनि प्रोटेक्टिङ इरोजन रिस्क सेडिमेन्ट ट्रान्सफर्स इन द रिभर अनि म्यानेज गर्ने अनि डिजाइन गर्ने कन्ट्रोल मेजर्स रिस्क पत्ता लगाउने अनि त्यो प्याटर्नहरू पत्ता लगाएर चाहिँ रिस्क पत्ता लगाउने अनि के अरे म्यानेज कसरी गर्छ र मोनिटरिङ कसरी गर्छ अनि त्यही नै हो। ट्रान्सपोर्ट अनि म्यानेज सेडिमेन्ट ट्रान्सपोर्ट र डिजाइन कन्ट्रोल मेजर्स अनि the parameter suspended sediment concentration, suspended sediment load, sediment yield and yield भनेको चाहिँ the rate at which the sediment is delivered from the specified area to the downstreams. The sediment delivered from the specified area to the downstream locations and that is mass per unit ton per kilometer square per year. Sediment के हो यो अनि कन्छ होइन yield अनि load भनेको चाहिँ amount of the sediment transported by the flow fluid within the specified period of time अनि sediment concentrations भनेको चाहिँ अनि amount of the sediment presented in a given volume of the water at the year. ग्राम पर लिटर अनि कन्सन्ट्रेसन चाहिँ सेडिमेन्ट लोड एन्ड टन पर इयर अनि यिल्ड भनेको चाहिँ टन पर किलोमिटर स्क्वायर पर इयर द्याट इज डेट एट विथ द सेडिमेन्ट ट्रान्सपोर्टेड फ्रम द अपस्ट्रिम स्पेसिफाइड एरिया टु द डाउनस्ट्रिम लोकेसन्स एन्ड मिनरलोजिकल क्यारेक्टर पार्टिकल द साइज डिस्ट्रिब्युसन स्पासियो टेम्पोरल भेराइबिलिटी सेडिमेन्ट डाइनामिक्स एन्ड ट्रेन्ड्स अनि डाटा निड टु मोनिटर अनि के अरे अर्ग्यानिक कन्टेन्ट डेन्सिटी अफ द सेडिमेन्ट्स टेम्परेचर एन्ड टर्बिडिटी sediment concentrations, total surface sediment concentration on total concentration sediment, suspension sediment load, suspension sediment load, sediment yield, and its spatio-temporal variability, sediment dynamics and trend, and in the sediment concentration and transport rate can vary spatially and temporally. Sediment concentration and transport rate and sediment concentration and transport rate and it can vary spatially and temporally. Helps in understanding the sediment dynamics and load. The sediment transports can vary any rates and can vary spatially or temporally, which helps to understanding the sediment dynamics and loads and trends, sediment dynamic and trends and particle size distributions and sediment transport behavior and depositional pattern and that represent the total amount of the sediment delivered to the particular locations over the specified period, often expressed as annual suspended sediment load and spatio-temporal variability and sediment concentration and transport rate can vary spatially and temporally, helps in understanding sediment dynamics and trend and particle size distribution, sediment transport behavior, depositional pattern के थियो त्यहाँ कसरी ट्रान्सपोर्ट हुन्छ होइन डिपोजिट कसरी हुन्छ अनि इरोजन कसरी हुन्छ अनि इरोजन कसरी हुन्छ, ट्रान्सपोर्ट कसरी हुन्छ र डिपोजिसनल प्याटर्न डिपोजिट कसरी हुन्छ अनि इरोजन ट्रान्सपोर्ट र डिपोजिट कसरी हुन्छ अनि त्यो हेरेर चाहिँ प्रेडिक्ट द इरोजन रिस्क अनि इरोजन रिस्क प्रेडिक्ट गर्ने कन्ट्रोल गर्ने र म्यानेज गर्ने थ्रु डिजाइनिङ एन्ड कन्ट्रोलिङ मेजर्स अनि म्यानेज दि सेडिमेन्ट ट्रान्सफर्स इन द रिभर and PSD sediment transfers behavior, depositional pattern, mineralogical pattern, sediment source, and the sediment and sediment source and the understand sediment provenance. organic content आणि sediment stability, nutrient cycling, and the habitat quality. Sediment stability, nutrient cycling, sediment stability, nutrient cycling, the habitat quality, and organic content. Sediment stability, nutrient quality, the habitat and quality, nutrient cycling. Sediment stability, nutrient cycling, the habitat quality, sediment cycling, nutrient quality, the habitat, nutrient cycling, and sediment quality and stability. Nutrient cycling, the habitat quality, and organic content. And determine the amount of the organ management results to influence sediment stability, nutrient cycling, habitat quality, sediment stability, and nutrient cycling, habitat quality, density of the sediments, and compactness or the pore indicate the compactness or the porosity of the sediments affecting its transportability and the settling behavior, affecting the transportability and the settling behavior, density of the sediments, and compactness or the porosity of the sediment affecting its transportability and the settling behavior, and temperature and turbidity, and sediment transfer dynamics and the sediment water interactions, and the transfer dynamics and sediment water interactions. Density and transportability and the settling and behavior, organic content, sediment and stability, nutrient cycling, habitat quality, mineralogical characteristics, sediment source and the sediment provenance, and mineralogical characteristics, sediment source and sediment provenance, and particle size distribution, sediment transport behavior, depositional pattern, particle size distribution, sediment transports and behavior, and the depositional pattern, and particle size distribution, sediment transport behavior, and depositional pattern, spatiotemporal variability, sediment dynamics and trend, spatiotemporal variability, and sediment transfers and the dynamics and the trend, and particle trend transfer behavior, depositional pattern, mineralogical characteristics, sediment source and the sediment provenance, and sediment source and sediment provenance, mineralogical characteristics, and organic content, and sediment stability, cycling, habitat qualities, density of sediments, transportability, and settling behavior, and temperature and turbidity, sediment transfer dynamics, and sediment water interactions. And sustainable sediment management seeks to maintain the long-term reservoir capacity. Sustainable sediment management seeks to maintain the long-term reservoir capacity. Sustainable and sediment management seeks to sustainable sediment management and it seems to maintain the long-term reservoir capacity, retarding the rate of the storage loss and eventually bringing the sediment inflow and the discharge into the balance while maximizing the unusable and maximizing usable storage capacity. Sustainable sediment management seeks to maintain any long-term reservoir capacity, seeks to maintain the any long-term reservoir capacity, retarding the rate of the storage loss and retarding the slowing the rate of the storage loss and long-term storage slowing retarding the rate of the storage loss and eventually bringing sediment and discharge into the balance while maximizing the retarding the rate of the sediment loss, storage loss and rate of the storage loss, storage and retarding slowdown of the story and eventually bringing the balance in between the discharge and the sediment inflow and, while maximizing the usual storage capacity and retarding the sediment and storage of the loss and the rate of the storage loss eventually bring the sediment inflow and the discharge into the balance while maximizing the unusable and while maximizing the usable storage capacity, hydropower productions or other benefits. Steps are development of the sediment management program for the either new or the existing reservoir and catchment oil upstream river reservoir or dam and get downstream which is hydraulics and the steps are the development for the anigated sediments management for either new or the existing program monitor and document the existing hydrohistoric conditions. Steps for development of the sediment management, steps for development sediment management program for either new or existing reservoir, steps for development of the sediment management program, steps for development sediment management program for either new or existing reservoir and for existing on development of sediment management program, development of the sediment management, how to develop the sediment management program, monitoring, documenting existing or the historical conditions, and monitoring and developing the documenting existing or the historical condition, monitoring and documenting the existing or historical condition, developing the design and the operational strategies, develop the design and operational strategy, monitoring and document the existing or the historical condition, monitoring and documenting the existing or historical conditions, develop the design and operational strategy, develop the design and operational strategy, monitor the effectiveness of monitoring and adjust the management practice, monitor the effectiveness, monitoring and adjust the management practice, and Monitor and document the existing or the historical conditions, monitoring and documenting the existing or historical conditions, and develop the design and optional strategy, develop the design and optional strategy, monitor and document the existing, monitoring and develop the any existing and operational strategy, and monitor and document the existing or the historical condition, monitoring and documenting the existing or the historical condition, monitoring the effectiveness, monitor effectiveness, monitoring and adjust the management practice, monitor effectiveness, monitoring and adjust the management practice. And monitoring the effectiveness and monitor the effectiveness, monitoring and adjust the management practice, monitor the effectiveness, monitoring and adjust the management practice, monitor and document the existing or the historical conditions, monitoring and developing and in documenting the, monitor and documenting the existing or the historical condition, monitor and documenting the existing or the historical conditions, develop design and operational strategy, develop design and operational strategy, monitor effectiveness, monitoring and adjustment management practice, and adjust the management practice. In the balance between the sediment inflow and the outflow of the occur at the reservoir, and in the management of the or by the as a result of the management of a natural process, and absent active management such as properly time gated operation to pass both water and sediment reservoir will fill the sediment until all usable storage is lost, and gated operations now sediment and reservoirs filled with sediment until usable storage is lost. If the delta reaches the dam and get the bed load is discharged over the spills where the reservoir is replaced by the water, and the reservoir will fill with the sediment until the all usable storage is lost, and the reservoir fill with sediment until the usable storage is lost, and a delta reaches the dam, the bed load is discharged over the spills when the reservoir is replaced by the water. And sustainable and sediment management, 6 to sustainable sediment management and sustainable and get 6 to maintain the long-term reservoir capacity, retarding the rate of the storage loss. Sustainable sediment management, 6 to maintain the long-term reservoir capacity, retarding the rate of the storage loss, and eventually bringing the sediment inflow and the discharge into the balance while maximizing the usable storage capacity, hydropower productions, or other benefits. Monitoring of sediment transport dynamic positions and discovery is required to determine the sediment transport rate, and development of the sediment management programs for the either new or existing reservoir will helps to following typical 3 steps, and monitoring and documenting existing or hydrological conditions, and determine the rate of the storage loss, identify the management alternatives, calibrate the sediment transport model, determine the rate of the sediment transports, and identify the management alternative, and calibrate the sediment transports model. And this will also typically include the organizations and review of all informations, available informations. This will typically include organizations and review of all available informations and the data on hydrology and the sediment yield, updated bathymetric mapping, and sediment course to obtain the grain size and bulk density data for the deposited sediments. It may be included operations of the gauge stations to collect suspended sediment data plus the sampling of the build material. And to document the existing historical condition, determine the rate of the storage loss, identify the sediment alternative management, and determine the rate of the storage loss, identify the management alternative, and calibrate the sediment transport model. Determine the nearest rate of the storage loss, identify the management, and determine the rate of storage loss, identify the management alternatives, calibrate the sediment transport model. The steps will typically include organizations and review of the all available the steps, and आणि sediment transport state of the storage loss and sediment alternative management alternative rate of storage loss and calibrate the sediment transport model identify the rate of storage of the loss and get a determine the sediment transport model and get a determine the management alternatives will require the review of all available information and data on the hydrology and the sediment yield. No, sediment yield updated bathymetric mapping and sediment cost to obtain the grain size, bulk density to deposited sediments, including the. It may also include the operation of the gauge stations to collect the suspended sediment data plus sampling of the bed material and essentially the gauge stations to collect suspended sediment data plus sampling of the bed material and develop and design of the operational strategy and develop design and operational strategy design for the sediment management will proceed through the conceptual preliminary and develop design and the operations develop the design and operational strategy and document the existing or the historical conditions and develop design and operational strategy and design operational strategy and the develop design for the sediment management will proceed through the and develop and for the design for the sediment management will the design for the sediment management design for the sediment management will proceed through the conceptual preliminary and the final design phase and through the conceptual preliminary the final design phase conceptual design phase begins with the definitions and more detailed evaluation of the management conceptual design phase and a preliminary the conceptual preliminary the final design phase and evaluation and management already including sediment transfer modeling of the favorable structural and alternatives and operating rules and development of the preliminary cost estimates and the environmental analysis conceptual analysis when selecting the implementation stage subsequent design phase may involve an and preliminary मला आणि के अरे preliminary costing estimates and the environmental analysis. And then त्यसपछि selecting implementing strategy also serve as a selections of the implementing strategies अनि यो environmental र अनि cost preliminary cost estimate and environmental analysis preliminary cost estimate and environmental strategies and also selected for basis of the implementing strategies subsequent design phase may involve more detail and modeling and subsequent detailed area analysis may involve more detailed modeling, including physical modeling, finalizing of the new operational rule, finalizing a new operational strategy and to be adapted and for the management and the design of the civil design for the structural measures, monitoring effectiveness, monitor effectiveness, monitoring and adjustment management practice, both short term and the monitor effectiveness, monitoring and adjustment management practice, both the short term and long term monitoring should be undertaken to provide effectiveness. Short-term monitoring can be used to develop the detailed information, including the IE period, and the long-term will determine and get whether the operational adjustments are required in the future or not. And frequency and duration of sampling and sediment monitoring, importance of represented sampling, focus on IDSARS events and impact on the major floods, subsequent and sediment sampling technique, that integrated point integrated turbidity measurement. Depth integrated sampling, point integrated sampling, and depth integrated point integrated and depth integrated EWI method, EDI method, and a single vertical samplers method, instantaneous sampling. Then time integrated sampling, instantaneous sampling, time integrated mass, depth integrated point integrated, depth integrated EWI method, EDI method, and equivalent with method, and suspense sediment monitoring, and then suspense sediment sampling, time integrated point integrated, time integrated, depth integrated, and get a point integrated, and instantaneous sampling, time integrated sampling, instantaneous sampling, time integrated sampling, instantaneous sampling, time integrated, depth integrated, point integrated, depth integrated, EDI, a single point vertical sampling, and bed sample physical traps, bed forms, and velocity meter, and vertical velocity of the bed material, and virtual velocity physical traps, bed forms of the velocity meter, and bed load sampling, bed material sampling, grab bucket type, vertical pipe type, drag bucket type, grab bucket type, vertical pipe type, and monitoring and documenting existing or the historical condition, develop design and operational strategy, monitor the effectiveness, monitor and adjust the management practice. Sediment in the suspended sediment and its monitoring method, direct measurement using the samplers and the optical method.